Two is limits and continuity analytically. So a lot of this will look familiar to the stuff we did in Unit 1, but now it's more just doing it mathematically and not having as many graphs to help you. So continuity, we've talked about what continuity is not. It's not when you have some kind of jump or a hole or an asymptote. So continuity is when I have a graph, and let's say it's a piecewise function where I have a parabola that stops here. And then let's say I have something linear that then picks up where this stopped and then keeps going. That's continuous everywhere, and including this point where the two pieces meet. But if this were to be an open circle there, that's discontinuous. That's that removable discontinuity, and the pieces can't be a jump where from the left and the right you're coming to different values. So the definition of continuity is when the left-sided limit and the right-side limit equal each other, which therefore means that the general limit exists because both sides match, and f of a, so it has that same value when I plug in x and it closes the hole, because without that piece there might be a hole. So in other words, limit exists, there are no holes. That's the simplest. So number one, we have what's called a piecewise function. We graphed these last year. And the problem is that this piece, which is a quadratic, is only when x values are less than 2. So it's to the left that way. And then this piece is linear with a positive slope, right, and a y-intercept of -17. And it's for the right of 2. So I've got to figure out, is it continuous at that break, or is there some kind of discontinuity? So what you should check is the limit from the left of 2, because it's asking at 2, of f of x. Is it equal to the limit as x approaches 2 from the right of f of x? I would check that first before anything else. Okay, so the left piece we already said was this one, because this is for x values to the left of 2. So that's going to tell us what are we doing here. I know it's going to be upside down because a negative in front of the x squared terms makes it do this somehow. I'm just guessing. And it's going to be an open circle because it doesn't equal that. Okay, so I'm going to just simply plug in 2 to see what value this gets. So I'm going to have 8 minus 4 times 2 squared. And then the other side I said was linear, and it's got positive slope. So it's doing something like this. Again, I just don't know if it's close. So I got to plug 2 on the right side. It'll be -17 plus 3 times 2. 2 squared is 4 times -4 is -16. 8 minus 16 is -8. So really when I plugged in 2, I got -8, which is way down here. Okay, and then the other side, 3 times 2 is 6. -17 plus 6 is -11. So that does not equal each other, so that means that the left-handed side limit does not equal the right-hand side limit, so then I know that this is discontinuous, or I'd say not continuous, because there's a jump. I want to show you too real quick just to help you see it. Here it is graphed on my phone, so you can see the left-hand side and the right-hand side, and you can see there's that jump there at 2. All right, so let's try to go a little faster now. Number 2, we're seeing, is it continuous at 4? So again, I'm checking the left, and I'm checking the right to see if they match. So the left is actually this bottom piece, because this says where x values are less than 4. So again, if you think of a number line, less than 4 is going to be this way to the left. So I'm going to see if 14 minus 3 times 4 is going to equal the right side, which is the greater than 4. 18 minus 4 squared would be 14 minus 12, which gets 2. Does that equal the same? 18 minus 4 squared is 16. That also equals 2. So it means that the limits equal each other, but now I got to make sure there's not a hole. So I need to check where it equals 4. So find the piece where there's the equal to the number. If I plug 4 into this, 14 minus 3 times 4, I'm going to get 2 again. So this is continuous. Because coming from the left and the right, I know that I'm coming to 2, and then I'll just do something like this. And I know that that hole is closed, so it's continuous. All right, and then number 3, be careful with this. This says at x equals -5. This is not a typo. These don't even match this, right? So the break is not happening where they're wanting to know, is it continuous or not? So really thinking, okay, at x is -5, which piece is going to contain that? Well, numbers less than 5 would contain the -5. So I'm only looking at this piece. What kind of piece is that? Well, that's linear. That's a y equals mx plus b, y equals 3x minus 20. It's always continuous. The only time there's a jump here is because it's a piecewise function. And so we've got something linear happening, and then we've got something quadratic happening. The jump can only happen at 5. So at -5, it's good because that was a linear piece. So beware that sometimes they like to trick you and pick an x value that's not even in where the split could be happening.